So of course another option for airflow estimation is using mass flow sensor. Now nobody in racing likes to use them. They're hated for various reasons, but this is a tool to help you calibrate the transfer function based on measured data. So on the x-axis you have frequency, and on the y-axis you have a back-calculated flow based on either AFR times fuel or a different model, throttle body model if you use that. But for right now, this is plotting the distribution of about 600,000 points from a test that I did on engine. So the spread here is over a tremendous variation of speeds and loads and cam position pairs. This is a VBT engine, so the VBT was exercised through its entire range, when collecting this data. So this shows the general correlation between frequency, or the raw sensor output, and the back calculated flow. So on this engine, you could definitely consider the mass flow sensor a viable option for load sensing. I do have the option here of actually transforming the raw frequency on the x-axis. So I have an option here to actually cube the values. So when you select that, it becomes a lot more linear. The relationship between the frequency cubed and the flow is much easier to extrapolate, so it would be much more user-friendly in terms of visually calibrating it the way that our users like to do things. But obviously you can see that it more heavily weights the higher load, and there's a higher density of support points in the lower loads here. But you can see in general that the response is fairly linear. And again, you have the option of filtering out based on how many standard deviations you are from the mean. So if you decrease this value, then it will pull away some of the outliers, decrease it some more, and then you can see some more of the outliers go away. And then in the same way as the throttle body model page, you can copy one by one from the fit to the curve, or you could copy the entire fit, and then you can also use the throttle body model as another mechanism of visualizing it. And there'll be a little bit more noise in that, because what I need to do actually is make it such that when you select the throttle body model, that there's a maximum pressure ratio that it allows. So these wild deviations here is where the throttle body model goes to crap as the pressure ratio across the throttle approaches unity, or approaches 1. But you can definitely see that behind this cloud is still a pretty good correlation there on from using the throttle body model as the air flow reference to against which you plot the frequency. And again, you have the option of erasing points. In this case, it may not be appropriate because those are valid points. The throttle body model by definition isn't good at wide open throttle, so you probably wouldn't want to delete those points. But if you were back on AFR times fuel, and you saw a obvious outlier here, you might want to remove that from the general data set. And of course, this is you would want to calibrate that so you didn't have this knee in the curve up top, but that's beyond the range that the engine needed. So anyway, again, if you use the mass flow sensor, that would certainly be a viable option, because again, it doesn't care about what the cams are doing. I mean, there's some areas where if you have a large amount of reversion, you may want to do some correction based on if you're using the flow sensor. But that's something that is fairly simple. You take a frequency and you turn it into a flow. Very direct, but almost universally hated. But anyway, this is the oh yeah, I forgot. You can also show the ratio graph on the mass flow sensor as well. So again, you want it to be around 1-to-1 in terms of the red dots versus the white line. That's what the green dots are. So where the red dots are high here, you have high green dots here, but it's normalized to 1-to-1 so that in areas that's hard to visually see here, you can line it up better by looking at the ratio graph. But anyway, this is a mechanism to help apply the mass flow sensor if we had a mechanism to use it in the ECU.